So now limiting reagent, percentage yield. These are the questions we are doing. Write the balanced chemical equation for the reaction of magnesium metal with oxygen gas to form magnesium oxide MgO. So this is the first thing that we are supposed to do. Magnesium metal is reacting with oxygen gas to produce magnesium oxide. We are supposed to write the balanced equation, and then we are going to write the mole ratio. If 10 grams of magnesium are mixed with 10 grams of oxygen, how many grams of magnesium oxide can be formed? What is the limiting reagent? Limiting reagent is the substance which completely gets used up, and the other substance which is remaining unreacted, that will be known as excess. So how many grams of excess reagent are left unconsumed, that is unused or unreacted by the reaction? So first of all, we are supposed to write down the reaction. Okay. So first of all, the equation. Magnesium is Mg, oxygen gas will be O2. The formula of magnesium oxide is MgO. We can easily balance this equation. This is 2, so I'll multiply this by 2 and this will become 2. We will write the mole ratio for the reaction. Magnesium is 2, this is 1, and this is 2. We will calculate now the moles of each one of these substances. Okay, so this is 10 grams divided by its relative atomic mass. Magnesium from the periodic table you can get, this is 24. This will give me the moles of magnesium. For oxygen is O2. This is also 10 grams. Oxygen is O2, 16 into 2, 32 is the molecular mass. This will give us the actual number of moles that we are trying to use in the reaction. So we will calculate this. Okay, so this is going to become 10 divided by 24. This will be 0.417. Same way we will calculate the moles of oxygen. This is going to be 10 divided by 32. This will be 0.3125. Okay. So we have calculated now here the moles of magnesium and moles of oxygen. Now here we are supposed to decide which is the limiting reagent and which is the excess. See, for this we will have to consider over here the mole ratio. Correct? The mole ratio over here is 2:1. So it means this is 0.417. The moles of oxygen required will be half of it. Okay. It means if this is 0.4 approximately, if I'm considering, half of it will become 0.2. It means here oxygen is more. This is in excess. So definitely here magnesium is the limiting reagent. I'm repeating this part explanation again, once again. We have calculated the number of moles by dividing the grams, that is the mass that is given, divided by its atomic mass and molecular mass over here. We got the moles of magnesium, we got the moles of oxygen. The next part is this is 0.4. Okay, this mole ratio is 2:1. So if 0.4 moles of magnesium is there, 2:1 means we are supposed to make half. So it is going to require 0.2 moles of oxygen. The moles of oxygen is more. It means this is excess. It means this is not completely going to get used up. This is the limiting reagent. It will completely get used up. So the actual moles ratio we are supposed to consider over here should be this. So just calculate half of this is how much. This is going to give me 0.417. This will be divided by 2. So 0. This is going to be, I can take it approximately 0.21. So the moles of oxygen that gets used up, this is 0.417. The moles of oxygen that is getting used up is 0.2. Okay. And the moles of magnesium oxide that will be produced, here you see this mole ratio is 2:2. So the moles of magnesium oxide produced again will be 0.417, because these both have to be equal. And this is supposed to be half. Okay, so magnesium is completely used up. That's the limiting reagent. How much magnesium oxide, MgO, will be produced? This will be multiplied by molecular mass of MgO. This will give me how many grams of MgO will be produced. So this will be magnesium is 24 plus oxygen is 16. This will give me 40. So this will be multiplied by 40. This will give me how much grams of magnesium oxide will be produced. So I'm going to calculate the mass of MgO produced. 0.417 multiplied by 40. 16.68 grams of magnesium oxide will be formed. Now this is excess. It means some amount of oxygen is going to remain unreacted. How much is this excess? You calculate, subtract and calculate. This much is used up. This much we are using. How much of it will remain? So calculate that. 0.3125 minus 0.2. This many moles of oxygen will remain. These many moles of oxygen are remaining. Multiply by the molecular mass. We will get how many grams of oxygen unreacted is remaining. So I'll just calculate that. RMM of oxygen is 32. This is 3.6. O2 is unreacted. So basically what is happening in this reaction, we are using here 10 grams of Mg. We are reacting with 10 grams of O2. This is going to give us magnesium oxide, MgO. 10 grams of magnesium completely is reacted. So at the end of the reaction, no magnesium is left. Okay, 6.4 grams of oxygen reacts. So this is getting used up out of 10 grams. How much of oxygen unreacted is remaining? 3.6 grams of oxygen unreacted. So 10 grams plus this. This will give me, this is the amount of magnesium oxide produced, 16.4 grams. See, there is little difference in value because I have considered some approximation. If you calculate accurate according to what these values you have used up, okay, half of this is not exactly 0.2. That's why that much little difference is there. So basically in this reaction, what is happening? 10 grams of magnesium, 10 grams of oxygen. Out of that, 10 grams of magnesium completely used up. Only 6.4 grams out of 10 grams is reacting, 3.6 is remaining, and this both you add, this many grams of magnesium oxide produced. If there are any questions, you can ask me. I will ask you to take down this question, and then you are going to solve other examples on your own.